Hey guys, it's Vince. Today in this video we're going to be discussing how to connect switches, whether they be at home or limit switches, to your G540 system. Now again, you can use this information with a singular drive system where again you're not using an integrated driver like a G540. However, the setup would be slightly different in the fact that you'd be connecting your switches signals to a breakout board. Right now we're going to keep it real basic. G540 system is one that I've had numerous questions on for those getting, newly acquainted with their systems, or someone that wants to step up to doing this, and I wanted to do a video to cover it because it really has to be done correctly so that we mitigate all of those signals potential for any EMI. So what we've got here is our GX16 panel mount male connector. You can see here it's labeled. And you can see the connections. On the back of that connector physically you'll see the numbered connections, 1, 2, and 3. You can see here that I've got a red C, and I'm just doing that to allocate the same way it is on a switch. And these switches are labeled home. It does not matter. It's completely arbitrary. C stands for common, of course. 2 would be NC, meaning how the switch is connected in a normally closed fashion. And then 3 would be shield drain. Okay? This is why when you wire switches, even though there's 2 connections on a switch, you would utilize a panel mount connector with 3 pins, because you're always going to have, in best practice, that shield drain connection, which will be connected to your ground bus somewhere inside of your electrical enclosure. This is best practice. You do not use 2 terminal connectors because the switch is 2 terminals. Always evolve yourself to look at in CNC. If you have whatever connections you have, if you're using shielded cable, add another connection, because that other connection is always going to be allocated to the shield drain. Okay, that's best practice. This way we're not soldering. I've seen guys solder to the top of the hoods and anything that's metal and conductive. We really want to keep it isolated. It's the simplest fashion, and again, it is best practice. So again, you've got your connections here. You can see I've color-coded these as well. Why I went with red is that if you're using my 22-2 double shielded cable, inside that cable, the leads are color-coded naturally, and red I always allocate to pin 1 on the actual GX16 male panel mount. 2 would be black, and that's why normally closed is text is black. 3 is shield drain. Now, inside my 22-2 double shielded cable, the shield drain does not have a drain lead because the cables, the leads inside are so thin, it actually utilizes the tin braided copper shield is what you'll be using, and you just twine it up, and being the cable, again, is so thin, it basically is like a 22 gauge lead. So once you do that, you would naturally solder it to the pin 3, and there's your shield drain. And once again, the connections here are real simple. Now, as we move over, these once again, and this is why I wanted to do a second half of the video to show you how these would install in an enclosure. I'm going to show you that because I get a lot of questions on these. What do you mean by panel mount? When I say to you guys that these are used for bulkhead pass-through, you're going to see that in the second half of the video. What we have here is the opposite end. This is the GX16 3-pin female connector, and you can see here's the cable here, the graphic for the cable. It's 22-2 double shielded cable. Now, why do I pick 22 gauge double shielded cable? 22 gauge double shielded cable, first of all, double shielding is required to mitigate EMI because all switches are very low voltage. The lower the voltage you're working with, the higher susceptibility to electromagnetic interference you have. That being said, 22-2 gives you the best, once again, of both worlds, and I say this in the second part of the video as well, in the sense that you have maximum flexibility because you guys are articulating a lot of sharper bends and whatnot, and of course you've got maximum EMI resistance due to the fact that again we're using 2 types of shielding which does high and low frequencies. This is imperative for our system stability. Okay, if you get a false signal trigger with these switches, it can cause all kinds of stability issues, and of course, God forbid, if a switch fails, even if it's wired normally closed, I've had guys say, oh, well, normally closed, it'll just stop the machine. I've had clients contact me with physical switches that have had them wired normally closed, at least to the best of their ability, and still have a crash. So guys, please don't ever feel that because you're using a switch in a certain format, you're going to be set for life. It's not the case. You guys have to perform maintenance on the system. However, if you perform maintenance on the system, hopefully, God willing, you'll find those kind of incidents before they actually turn into a catastrophe. So we mitigate disaster by, once again, being proactive. Right now, you can once again see the GX16 3-pin female connector. This connector plugs into this connector, and you'll see that in the second part of the video. But right now, you can see what I've got here. I've got my 22-2, and it's soldered in supposedly to this connector, and it runs over to your switch, which will be mounted on your chassis. And of course, we have our heat shrink here. Everything is done properly, okay, giving you that visual aspect. Now we're going to come over here to the wiring, and just to make sure everybody's on the same page, because everybody's at different levels that's watching this. You notice here that this connector mirrors this connector as far as the actual numbers on it, 1, 2, and 3, 1, 2, and 3. You're going to solder these connections on this cable the same way these connections are done here. So if you're using the red lead on this cable, it would go to pin 1, and then of course the black lead again would go to pin 2, and of course pin 3 would be the shield drain. Well, it's no different. Okay, so inside your enclosure, you would just match these, once again, red lead, black lead, and then green, which would typically indicate a drain consideration or a ground consideration. So again, these are the basic wiring for your GX16 3-pin coming from your cable, from your switch. This would be mounted on your chassis. And this is your GX16 3-pin panel mount connector, which is a bulkhead pass-through that will allow this plug to plug into it when this is mounted in the rear of the enclosure. And you'll see that once again in the next video. So what we have over here is our wiring diagram. Very, very simple. Okay? Ground bus. Now just to cover our ground bus, every system should have a ground bus. It's mandatory that you have a centralized ground for whatever accessories you're going to work with. Now, if you're not using switches, a ground bus may not be required. Okay? The big thing is if you start adding accessories, you need a centralized ground bus for any type of shield drainage that we're going to do. Now, you can also mitigate this if you were using actual ferrites. I've discussed this in previous videos. You can decide to use a ferrite and get away from using the ground bus with the shielding. That's totally up to the end user. However, in this application, I'm going to cover using a ground bus in the system. Either method works well. The big difference is again, when you use ferrites, you're not worrying about mounting the ground bus and so on and so forth. However, eventually, if you add enough components, typically a ground bus is still a very, very good thing to do. It's always nice to have it in the system, so to speak, for you to decide when to enable it, so to speak. So once again, we've got our generic image here for our power supply. Ground bus is here. You can see how the panel mount connector comes over. Once again, this can be mounted anywhere in the system you like. I mean, there's nothing really here that indicates you have to mount it here, and that's why I wanted to show you guys the system, because when I show you the system, you'll get a drift of as far as where to mount these, or, you know, at least in my system, where to mount them. It's totally up to you in your own personal enclosure where you'd like to go. 48-volt terminal splitter. Now, I get a lot of questions on this. This is very simple. Most 48-volt power supplies, or whatever power supply you have, has a limited number of terminals, whether it be positive or negative terminals. Now, when you have a limited number of negative terminals and you have multiple actual terminal requirements for switches, the more switches you have, the more terminal requirements you require. The issue is that you do not want to daisy chain. And what daisy chaining simply means is connecting this lead to this lead to this lead and so on and so forth, so that we have multiple switches all wired in sequence. That is not the best way to do this. What we want to do is isolate each switch individually, and we do that with a terminal splitter. And the terminal splitter is just that. You can see one lead coming from the negative terminal on the power supply over to the actual terminal splitter. And when it makes an actual conduction with this, it's going to split out this terminal on the power supply to all of these switches, giving them an individual location to mount without daisy chaining. Okay? So it takes more work to do this. All of my systems implement this. So when you guys ask for a quote from me, I don't daisy chain, and many of you already know that. I mean, if you review my videos, you'll see it. But there is more work involved doing this, much more work, because you're soldering a lead here, then all individual leads here. It can become quite taxing going through and seeing how it's all fabricated. But this is best practice. Now that we understand our terminal splitter and how this works, we are now going to come down here, and you can see on the G540 you've got your first 4 inputs. Well, the first 4 inputs on the terminal block on the G540 are just that. They're allocated to inputs, and you can see 1, 2, 3, 4. Okay, so inputs are arbitrary. They can be used for any type of switch. And you can see here I've got a touch plate wired on input 4. A touch plate is nothing more than a switch, guys. I mean, it's all it is. When we have conduction with our alligator clip, which is typically on our end mill, again, depending upon how fancy your touch plate is, when this alligator clip is on your end mill and the spindle comes down and makes contact with that alligator clip in the end mill, being you have conduction, it closes the switch. Boom, there you go. It triggers the signal, and next thing you know, your touch plate's active, and you'll get a retraction, and she'll go to the correct height, and you're ready to zero out and basically start machining. Well, this is the same principle here. The big thing to pay attention to with a touch plate, and why I'm starting with that first, because I get a lot of questions on this, is the fact that you want to make sure that your touch plate's base is insulated. And the reason you want the base insulated is because if it's metal, the touch plate's metal, and your chassis base plate is metal, where you're laying the touch plate, it's conductive. It's going to ground out on the chassis once you lay it on there. So you want an insulator underneath the touch plate. Now, whatever insulator you use, I highly recommend doing it in a way that it becomes part of the touch plate, because a lot of guys like to put pieces of paper underneath and this and that and the other thing. And the thing that they don't realize is every time you increase the diameter or the thickness of the touch plate, you find that your the spindle, when she retracts, you're going to find that the dimensions may not be accurate, because again, you've increased the thickness of the touch plate. So pay attention to that. I cannot emphasize that enough. What I recommend doing typically is you could always coat the bottom of a touch plate. You can either use a vinyl, you can use vinyl tape. Make it so that it's replaceable, whatever it is, because over time it may wear, but usually something solid that will become part of it is the best way to go and the most accurate way to go. Plastic is fine. If you guys have 3D printers, you can print the plastic casing for it. That's fine as well. Big thing is, once again, that it is a solid extension of the touch plate, so that we make sure that when we take a measurement, everything is congruent and nothing is going to change. Okay, and you can see how this is wired. Once again, we have our input from 4 coming over to the base plate, and then we have from the negative portion on the power supply, you can see V negative, here's the V negative terminal splitter, she comes over to the alligator clip, which would naturally be attached to the spindle end mill. Okay, and the reason we're doing that is when this is attached to the spindle's end mill, okay, if the chassis is grounded, this will not trigger the actual probe on Mach 3. We don't want to trigger that signal unless we actually make contact with the touch plate. So again, pay close attention to this. Setup is very, very critical, especially on your touch plate. A lot of guys ask me questions all the time on, my digitized light's on. Why is it always on? A lot of times it's on because you're not paying attention to how things are wired. So go through, validate what I've just said. It'll save you a lot of time. Now, switches, real simple. You can see we have 1, 2, 3 inputs on the G540. They come over, and you can see here 1 going to common, and then normally closed going to V negative on the power supply. Now, again, these are just for single switches. You can go series, you can go parallel. I wanted to keep this a simple, basic setup as possible. It's up to you on which way you'd like to go, and there's dozens of different wiring diagrams. I wanted to make this a real simple diagram for those wanting to get involved and do this and do it in a way that is, once again, not going to take hours upon hours of just deciphering diagrams. This is very basic. You have your one lead coming from your input, coming over to your common on the switch, normally closed on the switch, then simply goes over to your B negative terminal splitter. Okay, these as far as the connection. Now, once again, you're going to be using a GX16 3-pin. So it's not going to be wired just like this. This is just for quick reference. And again, I cannot emphasize that enough. I've had guys say that, well, how do I instigate using the panel mount connectors when I'm seeing it this way as far as just the drive being wired? You guys have to really add one and one in your mind as far as how the planning is going to go for designing your electrical enclosure, because you're never going to have things wired just like a diagram. Common sense prevails, You're going to have it wired in the sense of where you're going to have plugs and whatever else that are going to come inside here so everything connects, so to speak. So again, same thing on your Y home. And again, I've arbitrarily picked these inputs as far as per switch. You can mount any switch you'd like on whatever input. Okay, right now I've got on pin 1, I've got the X home switch, at least according to this diagram, and then on pin 2 input on the G540 I have the Y home. Now you can mix these up. You can put Y first. It's really up to you. It's completely arbitrary. Okay, but you can see how this is done. There's been many diagrams. I include many diagrams when you guys purchase the 540, but I wanted to do it in a way, once again, that I feel is as simple as possible. And I'm one of the few that actually show a ground bus being used, because I do get asked about that a lot. So again, I hope this part of the video has been helpful. At the end of the video, again, if you guys require quotes or questions, whatever you have, let me know. You'll see my contact information at the end of the video. Again, I hope this has been helpful, because again, I'm getting more and more questions on it, and I wanted to keep things simple. I know most of the time, every time I do a video, it generates more questions. The main thing is that I always ask you guys at least watch my videos twice, and please watch them taking notes. I don't expect anybody to sit here and memorize this or sit in front of a video and pause it every 2 seconds. A lot of times, if you take notes as you actually review a video, you're going to learn twice as much, because you're really digesting at a much quicker pace by writing and visualizing what's actually going on. So again, I hope that all makes sense. I'll go on now to the second part of the video. Once again, my contact information will be listed at the end. Thank you all for your support. Take care. Okay guys, this is the video to use in conjunction, of course, with the wiring diagram, which would be in the first part, that you guys are now ready for this part to actually see a physical enclosure and see exactly the components I'm talking about. Again, there's nothing like seeing these parts in real life, so you can visualize exactly what I'm saying. You can see I've got the rear of the enclosure right here, G540. Now my fan is mounted right here on my enclosure, so this area right here you will not be able to mount your GX16 panel mount connectors. Now, these are the same connectors I'm discussing in the wiring diagram for the switches. You can see this is the actual back of the actual panel mount, and it's labeled 1, 2, and 3 for your connections. And it's a male connector naturally, because again, it's got the prongs. It does have a notch so that the plug can only go in one way. Just goes in like that. Then of course you'll rotate the locking nut, and this makes it impossible to remove the female plug. And the female plug is of course this right here, and it is also labeled. Let's see if I can get in the light. There you go. You see the numbers. Essentially what you're going to be doing, as discussed in the wiring diagram, and I discussed this to a lot of guys in emails and they get kind of confused, is when I say bulkhead pass-through, what I'm discussing is the rear of the enclosure and where you'll be mounting your panel mount connectors, because these allow you to have bulkhead pass-through, which this would be your bulkhead. And basically what this allows to do is that your cable that you build for your switches or whatever accessory you're connecting would utilize the female connector, and the cable would naturally be run to your accessory, and then it would plug in to the GX16 with your bulkhead pass-through and pass-through, so that it could access your drive and your power supply and whatever else needs to be connected. So again, now that you have visualization of how this is, we'll cover real quick connections, because again, I get asked about this, and I've already covered it in the wiring diagram. Pin 1, if you were utilizing my 22-2 double shielded cable, and the reason I like double shielded cable to be used on switches, of course, is because there's such low voltage, and of course the lower the voltage, the higher susceptibility to EMI you have.
If you get a false signal with a switch, you can easily crash the system. That's why I'm not a fan of switches, and I've said this before, but I've had a lot of requests for this type of video, and that's why I'm making it. And overall, what we're looking at when you do your connections, just so everybody's on the same page, if you're using my 22.2 cable, and again 22 stands for the gauge, 22 is very small, very thin. It doesn't need to be heavy duty cable because again it needs maximum flexibility for bends and wherever you guys are mounting them. It allows you to do that very, very easily, and being it's double shielded, naturally again we've got the best of both worlds as far as EMI protection. Pin 1 would be red, my red lead inside the cable. Pin 2 would be black, which is going to the power supply. Now pin 1, which is red, would be coming from the G540 or whatever drive you're using for the signal. And then of course we're completing that signal with the negative terminal on the power supply, which would be pin 2. When the actual switch is in a normally closed operating setup, it would naturally break that as soon as the switch is actually depressed. So again, you can see exactly how this works. Pin 3 would be shield drain. Okay, so pin 1 red, pin 2 black, pin 3 ground, shield drain. Shield drain on 22.2 cable is simply the actual tin braided copper. There is no drain because again the cable is very, very thin as far as the internal leads inside it. So just keep that in mind. Okay, now naturally, like I said before, your plug also has numbers on it. You just, when you wire this end, you're just going to mirror this to this end. So whatever you did here, pin 1 red, pin 2 black, and pin 3 shield drain, you do the same thing here. And that's it. You're plugging it in. Now, on the opposite end, where your cable would be inserted here, of course, and it would be run to your switch, you do not ground on that end because you're grounding it inside the enclosure. I'll say it again. You only use ground on one end, so we mitigate any possibility for a ground loop. Okay? So you will not be using the ground going to your switch that's mounted on your chassis. You'll be using a ground coming in here to a ground bus, which will be mounted to the base of this enclosure, which is grounded due to actual conduction of the power supply, and that will properly ground and mitigate your ground drain so that we make sure that we dissipate any potential EMI. So now what I'm going to do is I'm going to show you inside the chassis what I'm discussing when I discuss a V-negative terminal splitter and also a ground bus, because I get guys that get confused on this. So when I say V-negative terminal splitter, you can see here I've got my power supply terminals all set up, and you can see against the wall right here, you can see terminals are labeled V plus, V negative, and V negative just means the V minus. Every power supply has a limited amount of terminals available to do connections with. This is why a terminal splitter is mandatory, on top of the fact you don't want a daisy chain. And daisy chain just simply means connecting a wire over and over and over again to multiple drives. We don't want to do that in best practice. The main reason that is that if you have a failure, you'll never really know it because everything is connected. You have to disconnect everything, and it's just bad practice overall as far as wiring, especially precision electronics. So what we're going to do now is, you can see here arbitrarily, and I've just picked the location where I typically would mount my actual V-negative terminal splitter, which is right here, and then my ground bus. And you'll notice the V-negative terminal splitter is easy to identify due to the fact that I'm using standoffs. Why am I using standoffs? Because I don't want to make conduction with the chassis itself. Okay? V-negative, I pick a terminal right here, attach a terminal, one lead, come over here and attach that lead to this terminal right here. And what I'm doing is I'm allowing myself then to naturally split all of those terminals on that power supply and get that same connection over here, and that's exactly what we're going for, so that we don't daisy chain any of the switches that we've just connected as far as when we have to attach pin 2 on the GX16 to the power supply, which would be V negative. Over here is your ground bus. Now your ground bus, you'll notice, does not have any standoffs. Why? Because our base of our chassis in my systems all have continuity because the chassis is grounded. Why is the chassis grounded? It's grounded automatically due to the fact that the power supply is conductive. It's metal, metal to metal, and this exterior portion of the power supply alleviates me having to run a ground. It grounds the entire chassis through conduction. Due to its size, it's very, very, very low ohms. So again, when you attach your shield drain, it will come right over here. And that shield drain then will be dissipated properly because the base of the chassis is grounded. I get a lot of questions on that. Conduction can be used to ground, guys, meaning a metal-to-metal object making actual contact with anything that's grounded. As long as it has a very low ohms rating, you're fine in doing that to actually get a grounded area or portion of your system, whatever you're trying to do. A lot of guys get confused with that. I get asked that all the time with spindles and whatnot. If your spindle is mounted on a CNC chassis and its metal body is making contact with its metal transmission as far as the Z-axis mount and whatnot, and it's making, in the chassis itself, as far as the CNC chassis is properly grounded, the CNC's spindle will be grounded as well through conduction. Now, will it be properly grounded in the sense of the ohms rating? We don't know, because unless you check that ohms, and it should be 3 or under. I've done that. I've said that number in previous videos. 3 or under is considered grounded. Everything else higher than that is not considered grounded for robotics. So please keep that in mind. Okay? But once again, these are mounted arbitrarily just for this video to give you an actual visual representation of what I'm discussing. And then you can see exactly what we were talking about here with your bulkhead pass-through. Just mounting these in the enclosure wherever you'd like. And once you do that, then you'll do your connections right here as far as how everything comes in. And again, pin 1 on your GX16 will always go as a direct signal to your G540. Okay, very, very simple. And again, I hope between the wiring diagram that I made you in conjunction with this to physically see a system before you, it makes things a little easier as far as how you want to go about planning your process of installing everything. The main thing is become very familiar with these connectors. Always understand that when you're soldering these connectors, you always want to start in a spot, wherever it may be on the pins, that is most inaccessible when you're actually looking at it in terms of starting. Because if you start somewhere incorrectly, you're going to solder yourself in a corner. And I'm telling you right now, it's not so big a deal on a 3-pin. You start doing 5 and 6-pin, you'll find out, you know, really how fast you'll learn how to solder, because it's very, very easy to say, oh, I'll just start over here on this side, and then when you start getting in the center, you're like screwed. So big thing here, when I start on a 3-pin, I always start at the bottom, and then I'll work on my outsides, because bottom's always tougher to do when you have wires in your way here. So keep that in mind. So again, I hope this part of the video has been helpful, along in conjunction, of course, with the wiring diagram. I think I've made it pretty damn clear as far as how you guys can go about and install your switches in a basic setup. Again, I've gotten asked this question numerous times, but just trying to get caught up in the shop is not the easiest thing to do right now. Things have been crazy. I hope the videos have been helpful. Thank you guys all for your support. Take care.